My name's Lee and welcome to Extra Maths. Today we are going to do a very important section for you. It's a section called compound angles. Now this section is one of the most demanding sections, and the only way to make sure that you really will be able to handle it more effectively is to know your formulas off by heart. In actual fact, they get given to you on your formula sheet, but from experience I have found that if it isn't in your head, it's very hard to recognize the questions. So let us start first of all talking about what they mean by compound angles. Right, if we talk about compound, helps if one uses the pen. If we talk about compound, what in your understanding is compound? Well, if we think about compound, anything that's compounded is made worse or more complicated. So up to now, when you have been working with trig in general, you've never had to deal with a very difficult angle. And if you have, the angle has been possible to simplify. So let's look at what I mean by that. In grade 11, you would have learned something like this. They would have said to you, evaluate the sine of 30 degrees plus 60 degrees. And then what you would have done is you would have said to yourself, well, first of all, brackets, let's do them first. This is going to become the sine of 90 degrees. And then once you were there, you would have gone along and said, well, the sine of 90 degrees is actually 1. And of course, that I'm getting from our special angles. And I don't know if you remember your special angles, but just to refresh your memory, you can learn them off a circle with a radius of 2. And we would work along here, marking off 0 degrees, 30 degrees, 60 degrees, 45 degrees, and then 60 degrees, and of course 90 degrees. Now, what I do to remember this is I always remember the following. I go 4, 3, 2, 1, 0, and then I go down again, 4, 3, 2, 1, 0. I then square root everything. So this becomes 0, 2. This one becomes 1 root 3. This one becomes root 2, root 2. And this becomes root 3, 1. And this one becomes 2, 0. So if I go over here, this would be the coordinate 2, 0. This would be the coordinate root 3, 1. This coordinate would be root 2, root 2. And this coordinate would be 1, root 3. And this last coordinate would be 0, 2. Now, if I was asking for the sine of 90 degrees, like I just did now, I would be saying that is the same as saying there's the 90-degree line. Sine, by definition, is the y value over the r value. Now, remember, we set r is equal to 2, so it would be 2 over 2, which equals 1. Right, let's pull the calculator up and show you that you actually have a very good alternative here. Now, if we look at this, I'm working out the sine of 90 degrees. So literally, I would literally go sine 90, and you can see there's your answer 1. So in actual fact, this calculator is quite able to handle this. So let's go now to another one. Let's take the cos of 30 degrees. Now, by definition, the cos of 30 degrees is the x value over the r. So if I go to my 30-degree arm, the x is going to be root 3, and the r is going to be 2. Now, if I pull the calculator up, let's see if that gives me the same value. And let's clear it. So we're going to go cos of 30. And there you go. You can see that the calculator has given you exactly the same answer. Now, we as teachers are aware that the calculator does do this. And so you'll find that maybe your teacher hasn't even stressed this with you. To a large extent, I show my pupils how the circle works. And then shortly after doing that, I said, well, look at this. You've got this calculator that can actually do it for you. So in actual fact, that's probably a better way to do it in the long run. Right, there's another way as well that you might have seen, and that involves right-angled triangles. You learn the triangle that's 90, that's 45 degrees, and that's 45 degrees, 1, 1, root 2. So if I want the sine of 45 degrees, now I would say, well, that's the same as saying the opposite over the hypotenuse, which is this. Now, of course, if I pull the calculator up at this stage and I use this, and I go the sine of 45 degrees, you'll see I get a slightly different looking answer. Now, that immediately makes us panic because we think, now hang on, they'll be able to see that I've not used the special angles, that I've actually used the calculator. Well, the good news is if you use that drawing what I did on the right-hand side with the circle, you would get that answer automatically. Now, I'm going to show you that, and we're going to go on from there. So if I go over here to sine 45 degrees, and I'm using the drawing I've got on the right-hand side, there's the 45 degrees. Let's just bring it down ever so slightly. And there you have root 2 over root 2. Well, sine by definition is the y value over the r. Now, that's the exact value the calculator gave you. So then you can actually fox us, because how do we know you didn't use this drawing with the circle? Anyhow, if you do use the triangles, it's not the end of the world, because if you have a look here, I'm sure you've heard your teacher talk about rationalizing expressions. If we rationalize, we are timesing so as to make sure that our denominator is not going to be a surd, and so therefore non-terminating, non-recurring. So what we do is we multiply by a convenient form of 1. The convenient form of 1 in this case would be root 2 over root 2 to make sure that those root 2's sort each other out. So this becomes root 2, and root 2 over root 2 is actually root 4. And what do you know about the root of 4? It's equal to 2. So in actual fact, you end up with exactly that same answer there. So now the good news is, in that case, the calculator will always help you out. So you just make sure that your calculator, your particular calculator, does this, and there's absolutely no problem with you using it. The teachers cannot prove that you actually used that, nor do we want to. It's just really that we want you to show the steps. So by saying to you, do not use a calculator, we're actually saying show all the steps. And if you use the calculator, that's absolutely fine. Right, let's go up to what I was talking about earlier. We sort of went a little bit on to the other stuff. Now, if we look here, I was talking about compound. Now, this is compound. Now, there are a few misunderstandings here, and I want to stop for just a few minutes, take this off for now, and just clear it up. You might say to me, but hang on a moment, isn't this the same as saying sine and distributing that sine in there? Well, the good news is it's not the same, and that's why up till this stage in your grade 11 work you haven't been encouraged to do that, because it does cause a lot of confusion. So looking over here, we have, let's see if it is. Let's take the sine times that and the sine times that, like good old distributive law, and let's see what happens. What did we find the answer to be? We found the answer to be 1. Now, if this is true, the answer I'm going to get is also going to be 1. Well, if I go here and I say, what is the sine of 30? Sine is the y value over the r value. Cos 60, here we are on this arm, and cos is root 3 over 2, which of course we have the same denominator, so we put the 2 there, and we get 1 plus root 3. All right, well, you can see that 1 plus root 3 over 2 certainly will not give you 1. And in fact, if you're not convinced, take your calculator, put it in, press the equal sign, and you'll see that it's actually more than 1. So clearly, this is not equal to that. Right, so what is? And this is where this whole section starts. This whole section revolves around teaching you formulas that does make this true. So I'm going to actually do the expansion here, although you've never seen it. And then I'm going to show you what does make it true. And then I'm going to talk to you about rules. So sine 30, cos 60, believe it or not, this horrific thing you're seeing now is actually going to give you the right answer. But of course, I will teach you a nice way to remember it so that you don't forget. So right, if we look at this, the sine of 30 is a half. The cos of 60 is also a half. The sine of 60 is root 3 over 2. And the cos of 30 is also root 3 over 2. Let's move it down a little bit. Uh-oh, a little bit too far. Let's just clean this up a little bit so we can refer to it. Okay, so now we're going to say a half times a half gives you a quarter. And this times this gives you 3 over 4. And of course, a quarter plus 3/4 makes 1. And as you can see now, that does give you the same answer. Now you'll say to me, oh my goodness gracious me, how on earth do you expect me to recognize this and know this? Well, as I said, it is in your formula sheet. The good news is I will show you a really nice way to remember it. Let's go through the summary of the formulas. Right, let's start with the cos one first of all. The first one is cos. Now I'm going to use star minus splish, for lack of a better thing. The reason I'm doing that is it really does not matter what angles we are working with. And so if I make it something abstract like this, when you get to the problems just now, you'll understand why it makes it easier. Now, if I look at this, this is cos star minus splish. As soon as I see a cos, I will think cos, cos, sine, sine. This is a negative, which means here I will have a positive. And then all I would do is I'd add in the star and the splish, the star and the splish, whatever it might be. So a cos formula always goes cos, cos, sine, sine. The sine, S-I-G-N, has always different to this one. So right, let's talk about the cos of star plus splish. So if I look at this now, what is the procedure? I know I'm going to go cos, cos, sine, sine. I also know that this sign here is a plus, so this one will be a minus. And then I know that the angles will be star, splish, star, splish. Now, as I said, it's on your formula sheet, but you'll see why I'm drilling this in a moment. Right, let's move now across to the sine formula. In fact, let's rather not use this orange pen. I don't think it shows up very nicely. Let's go back here and hit the black one again. Right, so now if I'm looking at sine, star minus splish, what makes this one different? Well, as soon as you see sine, you know that the S-I-G-N, the sign of the thing, will be the same as the one in the middle of the bracket. And instead of going cos, cos, sine, sine, you're going to go sine, cos, sine, cos. So we're going to go sine, cos, sine, cos. And as I said to you, this is a negative, so this will also be a negative. They keep the same sign. And then I'm going to have star, splish, but now notice I've gone star on the sign here, so I must have splish on the sign here and star on the cos. So if you like, when you do the sine and cos, the only difference is that the angles swap around in the second one here. Right, so now if we've got sine, star plus splish, we know again it's going to be sine, cos, sine, cos. And this is a plus, so this will be a plus. And we know this will be a star, splish, splish, star. Now, knowing those formulas is extremely helpful. As you've already seen, there's one example I've done that actually does do this and has shown you how this works. So let's take another one and convince ourselves that we are happy with these formulas. Let's take cos 45 degrees plus 45 degrees. Now, using our grade 11 method, we would straight away take this cos 45 plus 45 and say that is the same as saying the cos of 90 degrees. If we go back to our special angle diagram, we would know that we're dealing up here with coordinate 0, 2. And of course, cos is the x value over the radius, which is 2. So the x value is 0 over 2, which is 0. So we know the answer must be 0. So let's have a look now if we use this grade 12 stuff. So we've got cos 45 degrees plus 45 degrees, and we're ready to expand it. So this would become the cos of 45 degrees, the cos of 45 degrees. And then we know that because that was a plus, this would be a minus, sine 45 degrees, sine 45 degrees. Now we're going to go to our special angles or to our calculator, whichever one you want to use. And we know that this is root 2, root 2. So we're going to go along here. We're going to say the cos of 45 is root 2 over 2 times root 2 over 2 minus root 2 over 2 times root 2 over 2, which is incredibly good news because already you can see that if I've got something absolutely identical, subtract something also absolutely identical, it's going to give me 0. But let's be good and let's actually work it out. So we have root 2 times root 2, which is root 4, which is actually 2 over 4, minus 2 over 4. And then just to be really thorough, let's make it a half minus a half, which equals 0. So I think by now you've realized that those formulas perhaps are quite useful to know. Now let's go across to the first example and how they can actually ask you this. Now remember I said to you it's extremely important that you know these in your head. When you're in exam situations, it's really, really, really very difficult to sit and scrabble around on a formula sheet and look at the question and try and make sense of what it's asking. It's just so much better to have it in your head. I remember at the time they made a decision to include a formula sheet. I thought it was a wonderful idea. But in retrospect, I actually do think it's actually made your lives a little bit more difficult because you now don't have the information in your head. So please, this is one section I would strongly advise you to use your head for rather than the formula sheet. The formula sheet is handy in the sense that it would actually give you a little bit of, security in that if you do by any chance forget, you can look it up. But it's so much better in your head. Let's look at the first equation. Okay, now what they normally do in this section, because it is considered a sort of higher order kind of section. First of all, I must just tell you one of the nice things about this section is you actually get to revise just about every bit of work you did in trigonometry in grade 11 indirectly through this section. So what I would suggest you do is that as you go, you recap your grade 11 work on these sections. I will also mention, like I did with your special angles now, to help you sort of get comfortable. Now what they do, even though you've got a formula sheet, they sometimes give you something like this to lead in. So if I look here, it says cos A, cos B, sin A, sin B equals. So this is like, if you like, in a nice word, a hint. So what do we know? We know it's cos, cos, sin, sin. So if it's cos, cos, sin, sin, it must be the cos formula. We know that this is a different sign to that. And the angles involved are A and B. Now with the cos formula, if I'd gone B minus A or A minus B, it wouldn't have made a difference. But it does make a difference on the sine formula, so one must just be careful about that. Right, now it says hence. Now I had a friend who once used to say, the question that says hence or otherwise, it actually means hence or otherwise get it wrong. Now that's not quite as true as that, but the hence is usually there to give you a hint that what you've just said is going to help you with the next question. So what have you just said? You've just said that that can be condensed to that. So I think what they're hinting is look for this kind of condensing. So let's go across to the question now and see what they're on about. Right, so if we look over here, we've got the cos of 2 theta, cos theta, sine of 2 theta, sine theta. So of course it's cos, cos, sine, sine. So it's a cos shrink, which of course we suspected anyhow. We know that that was a plus, so we know that'll become a minus. And this would be 2 theta minus theta. Now look how much more user-friendly that second line appears. Right, underneath then we've got this one, and again, cos, cos, sine, sine, with a plus sign here. So we're going to go cos, and this time it's going to be 4 theta minus 3 theta. Right, so this means, and again, how much better does that look than that horribly long thing we had just now? So this becomes the cos of theta over the cos of theta, which is equal to 1. And you can see that's really not a bad question at all. Look, it was only worth 2 marks. I think that's a little bit mean. I probably would have given it 3, because I would have said, okay, you would have had to know this. Mind you, I suppose 2 is all right. I would have probably given you a mark for each of those and 1 there. But assuming that they gave you 1, because really that's the same process on the both of them. And so then you would get your answer over here. So very, very nice little question. And let's see what the next question is. Now it says, evaluate without a calculator. Now, as soon as you see the word without a calculator, as I've explained to you, sometimes it's all right to use a calculator, but you've got to fool the examiner and the teacher into believing that you are doing every step. So as long as you use the calculator to aid yourself, it's better. But this one, for now, I don't think the calculator is very important. Now you look at that and you think, oh my goodness, do I expand this out with that horrible long formula, that out, and that out? And hopefully you've realized that that would not be a good idea. In actual fact, if we look over here, you can see clearly here's your star and here's your splish. It's just your star and splish are a little bit more complicated than they've been. And now you know why when I did the formulas with you, I didn't use like A's and B's, because this way you can think in package deals. So your one package is 50 degrees plus theta, and your other package is 20 degrees plus theta. So I look, it's cos, sine, sine. So it's a cos formula again. And the star part of it is going to be 50 degrees plus theta. And then we know that that'll be an opposite sign, so it's a minus. And the splish part of it is going to be 20 degrees plus theta. Right, so that is equal to the cos of. Now, at this stage, it is best to simplify that, because even if we do get something that requires an expansion, it's only going to be one expansion instead of 4 different ones at the top there. So let's have a look at this. This is going to be 50 degrees plus theta. Remember that negative must impact both of these. So it's a minus 20 degrees minus theta, which means now if I look at this, that plus theta and that minus theta will fall away, and I've actually got the cos of 30 degrees, which the calculator will help you with, but I'm going to be good for a little bit of time. And if we look at the 30-degree arm, we know that this would be root 3, 1, radius is 2, and so the cos of 30 degrees is going to be root 3 over 2. And that would be the end of the question. So it looked hideous. It looked like you were going to be busy for at least a page. However, as you can see, by just recognizing, and because you know your formulas, you will recognize that you can condense that into a single thing. Okay, let's move on and look at another question. Now, of course, you remember in grade 11 when you did this section where you used your co-ratio reduction. And you can remember, I'm sure, the teacher talking to you about COCO rule, where the teacher would have said to you, sine becomes cosine. And the reason for that is co comes from the word complement. And the complement means adding up to 90 degrees. And I'm sure you remember the teacher also saying to you, whatever you do, avoid this if possible, unless they force you into it. Use normal reduction. Use the 180 minus, the 180 plus, the 360 minus. So in this case, I want you to prove it. And last year, the teacher would have shown you something along this line. They would have said to you, here's your circle, here's your angle theta, and then they would have said to you, right, well, this is 90 minus theta. They would have then dropped a perpendicular down like that, and they would have dropped a perpendicular down like that, and they would have said, this is the y value, this is the x value, this is the x value, this is the y value. And they probably would have shown you that if you took the sine of theta, it would have been the y value over the r. But if you took the sine of 90 minus theta, it would have been the x value over the r. But clearly, if you go back to the black drawing, that is the cos of theta. And likewise, if we go back to the pink one, we know that it's cos of 90 degrees minus theta would equal y over r. So we can see that those guys link and those guys link. Well, the good news is compound angles is giving you another way to show that this is true. So let's have a look how we're going to do that. Let's take this off, and let's take this off. In fact, let's take the whole lot off, because that was just a recap anyhow of old work. Right, so going over here, if I have to prove something, then I always work left-hand side, right-hand side. Just remember, it's not good enough to just say, this is true. If you go to court and they say, prove that you are innocent, you can't just say, well, look, I'm looking good today, and so therefore I'm innocent. They will want you to present evidence that it's true. So with this, they want you to present evidence and to show working of how you get to that. Yes, we know it's true from grade 11, and certainly from what I've just shown you, again, you know it's true. But I want you to actually present evidence to the examiner or your teacher on this. So we would call this the left-hand side, and we would call this the right-hand side. And our object is to prove them equal. Now the left-hand side is the more complex part. So we're going to take sine 90 degrees minus alpha. And we're going to say, okay, but we've got a way to expand this now. We've learned that if we get this and it's a sine, we can go sine, cos. We can take the same sine as that, and we know that this will be 90 and alpha and 90. Right, now it's a matter of just using it. The sine of 90, if we go to our special angles, will be 2 over 2. But now I'm starting to get lazy, and I'm going to use the calculator, which is a little bit in my brain, so we're just going to do it, times cos alpha minus, and there we can see we've got sine alpha. And the cos of 90, if we use our special angle diagram, will be 0 over 2, which I'm going to also just use the calculator version, which is 0, which then gives you cos alpha minus 0, which is cos alpha. Of course, you don't have to show that. I'm just being good, which is equal to the right-hand side. And so you have proved that that particular reduction is true. We could have also proved the more traditional ones. So let's take one of the more traditional ones. Let us take, which one's not a pleasant one? Let's take sine 180 degrees plus theta. And let's prove it. We know that that will equal minus sine theta. So let's start on the left-hand side, and we can say that that will be the sine of 180 degrees, the cos of theta, plus the sine of theta, the cos of 180 degrees. Okay, now believe it or not, that is considered a special angle, and you don't have to reduce it. Because if you think about the drawing I did earlier on, it was a circle. And if this coordinate is 2, 0, and this coordinate is 0, 2, then when I get over here, this coordinate is minus 2, 0. There's your 180 degrees. Your radius is 2. So the sine of 180 would be 0 over 2 times cos theta. And that's sine theta, and the cos of 180 will be negative 2 over 2. And of course, your calculator will do this, and they'll be none the wiser. That will become 0, because 0 times anything is 0. And this is going to be plus sine theta times minus 1, which is actually minus sine theta, which is your right-hand side. Isn't that just amazing that you can actually prove these a completely different way to last year? And you can actually get some understanding as to how you can get these things. If you ever forget them, you can just expand and work them out. But I'm sure by now they are so well ingrained in your minds, you will not forget them. Let's move to the next question. Right, this one says calculate the value of sine 75 degrees plus cos 75 degrees without using a calculator. Now, the good news is that you could actually get this answer on the calculator quite accurately. Let's just pull this calculator up. Let's clear it from the last question, and let's go the sine of 75 degrees. Now, you can see there it comes out root 6 plus root 2 over 4. And unfortunately, if you did that, they would know you used a calculator. So this is really just a checking device for you. So once you finish the question, if you want to make sure that you are right, you can always check it by using this wonderful calculator and sorting it out. I hate to tell you that a few years ago, people were not lucky to have these wonderful calculators that do all these wonderful tricks. Right, let's have a look now at what we would do, assuming we were going to be good and not use the calculator. First of all, I just want to spend some time talking about if I just asked you to evaluate, say, let's make it the sine of 15 degrees. This isn't the question. I just want to clarify some thinking here. Now, again, if we pulled up the calculator and we did that, we would know the answer. So let's just get it up. All clear. Let's go sine 15 degrees, root 6 minus root 2 over 4. Okay, so let's put it down. It's root 6 minus root 2 over 4. We know that that is definitely the answer. I'm going to show you how we can do that without the calculator. Now, when we get asked a question like this, the best thing to do is to look for two special angles that when added or subtracted give me 15 degrees. So, in the case of 15 degrees, we have two choices. Do you agree with me? I could have said the sine of 45 degrees minus 30, or I could have said the sine of 60 degrees minus 45 degrees. Now, in actual fact, it doesn't matter which one you choose. Whichever one you choose, if you work it out, you will find you get exactly the same answers the calculator got. So I'm going to do the first one, just to show you how this works. So now you can see I've made this a compound angle consisting of two parts so that I can use my expansion. And in doing that, I'm going to get things that I can actually just work on special angles. So having a look here, it's a sine expansion. So I'm going to go sine, cos, sine, cos. I'm going to go 45 degrees, 30 degrees. Take the same sine as that. This must now be the 30, and this must be the 45. Whatever you do, remember, if that's 45, that must be 30. Right, so this gives me the sine of 45, which I'm going to do from memory, is root 2 over 2. The cos of 30, which is root 3 over 2. The sine of 30, which is a half. And the cos of 45, which is root 2 over 2. And as I say, you're welcome to use any method to get those out. And now we're ready to simplify this. So this will become root 6 over 4. And this is going to become root 2 over 4. And look at that. Isn't that just amazing? You've got root 6 minus root 2 over 4, which is exactly what the calculator produced. So yes, that's just a wonderful example of how you can do this and get the answer the calculator got. And obviously, they would know if you just wrote this down that you had not done it properly, that in actual fact you had just used your calculator. So please don't try that, especially when they say without using a calculator. Right, so let's go back to the actual question now. In fact, before I do, I'm just going to clear this off, because we're basically going to be repeating this process using the ones above. Now, we've got sine 75 degrees plus cos 75 degrees. Let's start with the sine 75. Now, fortunately, they're both 75 degrees, but there's no reason why I couldn't have had, say, sine 75 and cos 15 degrees. And then you would have used the one expansion on the one and another expansion on the other. So let's start over here with this one first. So using the pink one, we can say this can be replaced with sine cos. Well, first of all, let's decide what we're going to call this. We're going to say this is the sine of. Now, what two special angles can I add that will give me 75? Well, 45 degrees and 30 will work well. So this becomes sine cos, sine cos. We want to put 45 degrees here, 30 degrees here, the same sign as that, the 30 here, the 45 there. Right, now we go across to this one. But before we do, we put our plus sign and we say, okay, what can I do to this one? Well, again, this could be written as the cos of 45 degrees plus 30. I don't think there is another alternative for that. I have had pupils in the past say to me, well, why can't we say 90 minus 15? Well, we can, but do you know 15? So that means you would do that and then still have to expand the 15, which would mean a whole lot of extra work, which is really not a good idea. Right, so let's go over here. This is now cos expansion, so we know it's going to be cos, cos, sine, sine. And we know that this will be a different sign to here. It will be a minus. And we know it will be 45 and 30, 45 and 30. I've gone a little bit close to the edge there. I hope you can see that all right. Right, so now going to this pink one, we now have special angles all the way through. So let's change it. So the sine of 45 is root 2 over 2. The cos of 30 is root 3 over 2. The sine of 30 is a half. And this is root 2 over 2. Plus, now the good news is this is a plus sign. If this had been a minus sign, I would have had to keep the bracket there, work this out, and then distribute the negative through. So the good news is I don't have to do that in this case. So cos of 45 is root 2 over 2. The cos of 30 is root 3 over 2 minus root 2 over 2 times a half. Now, of course, we can simplify this all, but in actual fact, if we look here, that and that are like terms, and one is a plus and one's a minus, so I can actually get rid of that immediately. And I would do that because it just makes your arithmetic much easier. Right, so going back to this now, I have root 6 over 4 plus root 6 over 4. which then becomes, putting it all over 4, root 6 plus root 6, which then gives me 2 root 6 over 4. And the good news is that divides into there. And so my final answer will be root 6 over 2. Okay, so nice little question. Let's just pull up the calculator and see whether the calculator would have given me that answer. So I was doing the sine of 75 degrees plus the cos of 75 degrees. And there you go, you can see quite clearly it's root 6 over 2. So the calculator is extremely, extremely useful to check your answers in this particular section. Right, so it's a very nice question. You will see various versions of this. They do ask it in all sorts of ways. What is quite nice is when you have something like this happen, it just cuts down the work. But you know, if you hadn't have done that, if you had had plus root 2 over 4, and then over here minus root 2 over 4 in the very next step, that would have gone. So it wouldn't have made a difference if you did that or not. Right, let's move to the next question. Now, of course, as all maths goes, we always try to complicate issues a little bit by building on questions. Now, the reason we do this is called scaffolding. And the reason we do this is we're trying to help you. Instead of just giving you the last question and saying to you, well, you know what, just work it out, we try to give you parts to help you to understand. Now, in this question, they are asking you to complete an expansion, which of course you have on the formula sheet. Then they're asking you to derive expansions, various other expansions, and to prove something new. And this is really very interesting. So let's have a look at it. Complete the expansion. Well, that's no problem. We know by now that will be cos A, cos B, plus sine A, sine B. Now it says, given the above formula, in other words, using this, derive, what does that mean? Derive means from that formula, find a new formula. Find a new formula for sine A plus B. But hang on a moment, this formula is cos A minus B, and I'm asking for sine A plus B. Now that's not a huge problem. Let's write down what we know. We know that cos A minus B is equal to cos A, cos B, plus sine A, sine B. And what I want to do is I want to find a formula for sine A plus B. So the question we've got to ask ourselves is, can we find a way to change sine to cos? And yes, we can. We can say that this is equal to, let's make it a cos because that's what I want, the cos of 90 degrees minus A plus B. Now that's a good start, but you see that that's still not going to really help me out because it's got to take the formula that gets this using. And as it stood, if I put it straight in, I'd be back to that in no time. So what I'm going to do is I'm going to shuffle around these terms. So I'm first of all going to distribute the negative through. So I'm going to say that's minus A, and this is minus B. And then I'm going to find a new way to group them. I'm going to group like that. Now this is going to be my star, if you like, and that's going to be my splish. Now again, I'm emphasizing again why I use the star and splish, because as you can see, the star could be 2 or 3 angles together. In fact, just the other day in class, I was doing a question along these lines, which I'll show you just now. And if you hadn't been aware of this, you could have got really bogged down in a whole lot of really unpleasant calculations. So right, let's go over here. Now knowing that, let's go back to the black pen. I can now say this is the cos of 90 degrees minus A, the cos of B, plus the sine of 90 degrees minus A, the sine of B, which is equal to. Now we know from co-ratios that as soon as I see a 90, I change the cos to a sine using the COCO rule that I was showing you earlier on, that the teacher would have shown you, that sine becomes cosine. And of course, cosine becomes sine. That's cos B. And this one is plus. And then what do we know about sine 90 minus? Well, that is going to become cos A sine B. And if you have a look here, isn't that the formula that we wrote down earlier on? That sine A plus B is actually equal to sine A cos B plus, and if you like, you could change the order, but we might as well just leave it like this. Do you agree with me that if I write it this way or this way, that's exactly the same thing? It's like saying 2 times 3 or 3 times 2. Absolutely no difference between those two things there. All right, so in the light of that, we've now completed the next formula, which is quite useful. And you can see I found a way to prove that formula I wrote down using one of the other formulas. In actual fact, the cos A minus B formula is considered the primary formula. And we can derive all the others using this one. And in fact, that would give you 3 little fun exercises to do if you feel like it. You could go and have a look at how you get from this one to cos A plus B. You've just seen how A plus B for sine worked. Maybe try an A minus B and see how that would work. It would give you a good idea of how they ask it. Right, let's go up to the question there. Now it says prove that cos 2A is equal to that. Now, prove that. Hopefully they're asking you to use that same expansion. I think they did say given the above formula, yes, so it will still apply to this question. We need to again use that one to get us a formula for cos 2A. So what do we know? We know that cos A minus B is cos A cos B plus sine A sine B. Now they want a formula for cos 2A, which of course could be written as cos A plus A. And normally it would be absolutely fine to extend that out. But since they've asked me to use this one, I would have to write it as cos A minus minus A. Do you agree a minus minus would make a plus and it all would work very nicely? So this becomes cos A cos minus A plus sine A sine minus A. All right, now as I said to you earlier on, this is a section where we get to recap a lot of your grade 11 work. So let's talk about negative A. Where are we if we talk about negative A? Well, negative A means we are measuring in an anti-clockwise direction. Oh, sorry, a clockwise direction, negative A. So that means we are actually in the 4th quadrant. In the 4th quadrant, the only ratio that is positive is cos. Sine is negative. So if I go back here, I can say this is cos A. And because we are in the 4th quadrant, that will just be cos A. That will be sine A. And then because we're in the 4th quadrant, this will become minus sine A. Notice I used a bracket there. The reason I did that is that if you didn't, it could get confusing about whether we are actually adding, or rather in this case subtracting, or multiplying. So just be safe rather than sorry. Use brackets and utilize them wherever possible. They always make your life easier. Right, so this is equal to cos squared A, and a plus times a minus is minus sine squared A. And there we have a formula for cos 2A. Now, of course, those of you that have done this section already would recognize that formula and realize that there are 2 others that go with this. And I'm going to do them while we're here because it sort of fits in at this moment in time. These are what we call our double angle formulas. Okay, and now if we look at this one, we could change this cos using what I call the 3 ugly sisters to 1 minus sine squared A. And you'll say, eek, what are the 3 ugly sisters? Let's recap. Last year's work, you know that cos squared theta plus sine squared theta equals 1. And so we could say that sine squared theta equals 1 minus cos squared theta, and cos squared theta is 1 minus sine squared theta. So there they are. I call them the 3 ugly sisters, and you can see the one I've implemented is this one here. that 1 minus sine squared is equal to cos squared. Now, what is the point of this? The point of this is I've now changed my formula to only contain sines. So it's 1 minus 2 sine squared a. And if you like, that is the second formula for cos 2a. Now, on the formula sheet, you are also given all three of these. But once again, my advice to you is just know them. It's so much better in your brain. It helps you to recognize what to do in your questions. And when we start doing identities that are a little bit more complex just now, you will see that if you know these things off by heart, it's just so much easier to recognize what to do. The last possible version of this is if I went back again to this top one here. And this time I change this. So I would say, right, that's equal to cos squared a minus, and in place of the sine squared, I'm going to replace with this, 1 minus cos squared a. All right, the good news is if I do that, this is going to become cos squared a minus 1 plus cos squared a, which then gives you 2 cos squared a minus 1. And there's your third formula for cos 2a. Now you're saying at this stage, whew, that's hectic going. Yes, it is. But it's so worth knowing this. In fact, I'm so passionate about you knowing your formulas that I make my pupils write little tests for about 10 marks on theory. And they've got to keep on rewriting till they get 10 out of 10. Because if they know it, it just makes the whole section much more doable. Right, now the good news is that the sine 2a formula only has one formula. So let's look at sine 2a. Do you agree with me that that would mean the sine of a plus a? Let's move the screen up a little bit. Which is equal to, using the expansion, sine cos. We know it'll take the same sign as that. It'll be a, b, and, oh, look what I'm doing. Nearly making a huge mistake here, guys. I was thinking, why don't I get like terms? Okay, that'll be an A and an A. So that'll be cos A, sine A, cos A. And of course, you can see that these are now like terms. So we're going to get 2 sine A, cos A. And so the good news is that is the one and only formula for sine 2A. I'm sure you're relieved to know that there's only one of them. So at the moment, there are 4 for the compound angles, and there are another 4 for the double angle. So there are 8 new formulas that you need to know this year. The good news is that's basically that. You don't need to know any more than that. That's all the new work you need to know. So let's move to the next question. Okay, now you can see without using a calculator coming in here again. So again, they're saying to you, even if you are using the calculator, make sure you show all steps so they are unaware that you are using it. And they ask you to simplify it. Just before I start this is a tricky way of writing it. In actual fact, this would look less scary if we wrote sine of 140 degrees, sine 80 degrees. Oops, I nearly made that line a little bit too long. Minus sine 220 degrees, sine 10 degrees, all over tan minus 40 degrees. Somehow that would have looked less scary than what was written there. But you agree with me that it means exactly the same thing. It's really just a matter of preference. So I'm going to do it as it stood, just so you can see. But in actual fact, it won't make a difference if you rewrote it like that. So let's take that away and stick with what the question actually said. Right, now the first thing we're going to do is we're going to reduce all these angles. So 140 degrees is actually 180 degrees minus 40. 80 is already acute, so we're going to leave it alone. 220 can be written as 180 degrees plus 40. 10 degrees is already acute, and in fact that bracket is not really necessary there, but they've put it there so it's fine. And of course this is a fourth quadrant angle. And what do we know about tan in the fourth quadrant? Tan in the fourth is a negative. So that's cool. We know what we're going to do there. So let's go to the step here. So now we say the sine of 140 in the second quadrant, sine is positive, so it's the sine of 40 degrees, times the sine of 80 degrees minus, now over here, this is the third quadrant. We know in the third quadrant, sine is negative. Notice my use of the brackets again. This way we avoid problems for later. And over here, I've got 1 over, and tan in the fourth is a negative, so it's negative tan 40 degrees. Now, the good news is when they start this kind of thing, they're actually integrating your grade 11 work with your grade 12, because so far what you've done is just pure grade 11 work. So it actually makes your life so much easier. So, right, if we look over here, I've got a negative, and a negative. So overall, I know that that's going to be a negative. And that's worth making that decision at this stage. So we have sine 40 times sine 80. As I say, overall a negative. I've got sine 40 over here. Sine 10 degrees here. And over here, tan, we know, is sine over cos. Okay, and it's a layered fraction, and we know that those are never fun, but it's absolutely fine. We're going to be great on this. So it's sine 40, sine 80, minus sine 40, sine 10 degrees. And the good news is this I can tip in times. I can say times cos 40 over sine 40. And that's good news because the sine 40s will divide out. Okay, so life is looking slightly better. Let's keep going. So now we have sine 40, sine 80, minus sine 10, cos 40. Now we know we've got 4 things here. However, can you see that it's not taking the form of one of our formulas? Now, if we wanted to, we can easily do that. We know that we've got the choice of going cos, cos, sine, sine, or we can go sine, cos, sine, cos. Now, if I look at this, this is already sine, cos. So it makes sense to me to go here and make this a sine and this a cos. Let's leave this alone for now. Now, of course, we know that if we're going to do that, ideally this must be a 10 degrees. Now, is that true that that would happen? Yes, it is. Why? Sine of 80 degrees is the same as saying the sine of 90 degrees minus 10 degrees. And of course, that we know will become cos 10 degrees from our grade 11 work. So as you can see there, it is very clear that you can actually do that. So we've already got that sorted. So let's take off this grade 11 work. And let's go back here. And this, of course, is the sine of 40 degrees. Now, that's very good news because now I've got sine, cos, which means it's a sine expansion. And remember I said to you that with a sine expansion where we're retracting it, it is very important which angle you put first. Because first of all, we know that this is a minus, so that will be a minus. And yes, if I go 40 minus 10 or 10 minus 40, that's 2 different things, especially when it comes to sine, not with cos, but with sine. Now, I say not with cos. Well, why is that? Well, if I go 40 minus 10, or I go cos 10 minus 40, this gives me the cos of 30, and this gives me the cos of minus 30. And of course, it's in the 4th quadrant, and what do we know about cos there? It's positive. So that would be equivalent to that. So just to clarify that so that you don't get confused later, the cos one is absolutely not a problem. The sine one is, so just be aware of that and be careful. Right, so still, since we're working with sine, let's go back to the question. Now we know that it's 40 degrees is the A value, because remember it was star, splish, splish, star. So it's 40 degrees and it's minus 10 degrees, which means we are dealing with the sine of 30 degrees, and the sine of 30 degrees is a half. And isn't that just so nice? That horribly complicated question just sorted itself out and came out with a nice little answer like a half. Again, if you really wanted to, you could check it using the calculator. I'm not going to do it. You've got calculators you can see for yourselves. But of course, they would know you used a calculator, you just produced the answer. Just for a matter of interest, I want to stop for a few seconds and talk about an alternate solution. If I go back here to sine 40, sine 80, minus sine 10, cos 40. You could have also gone to the cos, sine version, because it's not really hard to change these things. We know that if we want to make this a cos, we've just got to make sure that these angles add up to 90. So this would be cos 50, and this would become the cos of 10 degrees. This would stay as it is because I want to keep 10 degrees, but this one would become the sine of 50 degrees. Now if you look at that, cos, sine, it's a cos shrink, and it's going to be 50 degrees. And remember, with cos, we use the opposite sign. And this gives us the cos of 60 degrees, which is a half. So yes, there's absolutely nothing wrong with going to one of the other formulas. It really doesn't matter. I personally prefer to use the cos. The cos is just an easier formula to work with because it's very clear. Cos, sine, you know exactly what's going on. And it also doesn't matter which order we take our angles in. So definitely for me, my first preference would be to go to the cos expansion rather than the sine one. But it's absolutely fine. It really doesn't matter. It's your personal preference. Right, moving on to the next question. Here we have prove an identity. Now, you've got to be a little bit aware in this section that it sort of turns what you learned about identities in grade 11 a little bit on its head. Because now we no longer have the same kind of angle on the left and the right-hand side. We have very different kinds of angles. In fact, on this left-hand side, we've got a minus a, 180 plus a. But that wouldn't be such a big surprise for you because you would have seen something similar in grade 11. So we're not too worried about that. However, on this side, we've got a 2a. And a 2a is something totally different for us. Now, my advice to you is always start on the side with the worst angles. But if your other side has got reduction in it and tan in it, then start on the other side. So I'm going to start on this side, get rid of tan, get rid of these reductions. So on the left-hand side, I have got cos A. What do I know about this? It's fourth quadrant, so it's the same as saying cos A. Over here, I've got 180 plus A, which I know is the same as saying minus sine A. And here I've got tan, which is the same as saying sine A over cos A. Right, so I've got cos A. This is cos A. A minus times a plus is a minus. That's going to be sine squared A over cos A. Right, this then gives you cos A, and of course the rule is we normally work with our brackets first. So it makes sense here to put this over a common denominator, which will give me cos squared A minus sine squared A. Just to make sure you're right here, remember 1 will divide into cos A times, and cos A times that cos A will give me cos squared A. This one, cos A goes into cos A once, and 1 times that will leave me as that. Right, now the good news is that divides into that, which leaves me with cos squared A minus sine squared A. And if you look back to your double angle formulas, this is the same as saying that, which is the right-hand side. Now you can see why I said to you it's actually worth knowing these formulas. So as soon as I see that, I think, oh, I'm finished. It's actually complete. And I don't have to worry about it anymore, which is really nice. Okay, so that takes me to the end of that question. I just want to quickly recap with you a little bit of grade 11 thinking on identities. I'll just remind you how it used to work. The first thing we used to do is choose the most difficult side. The second thing we would do is we would look for our square identities, which I call the ugly sisters. And the reason we would look for them is to reduce two things to one. We certainly do not want to make one thing 2 because then it just makes it more complicated and harder to work with. So definitely it makes more sense to look for something where 2 things can become 1. Right, after having done that, the next thing we would do is we would change to sine and cos. So in other words, our tans would go. And then we would use our basic algebra. Now, what do I mean by basic algebra? I would mean your fractions, like we did with the common denominator just now. I would also mean factorization, or anything else we've learned to do when simplifying. So that's what I mean by basic algebra. Now, after having done that, I do a recycle. So I say, okay, let's go back up here now, and I pass it through that again. Now, if I pass it through the second time and nothing changes, and I still have not managed to prove the other side, I have a choice of 2 approaches at this stage. The first approach is if I have got something like this looking at me, then I may, because of that, I may change this to cos squared x plus sine squared x. And you'll say to me, but hang on a moment, you've just told us it's not a good idea to change 2 things to 1 thing to 2 things. It's better to have 2 things changed to 1 thing. Well, yes, I have told you that. But remember, you've actually got to a point where you actually can't do much else. So this would then become cos squared x plus 2 sine x cos x plus sine squared x. And that would then factorize to cos x plus sine x, or squared, which is nice, and we can then carry on working. The other option we have is if we're looking at something like this. And what we would do in this case is we would times by a convenient form of 1. In this case, my convenient form of 1 would be this thing with a different sign, as you can see. Now, if I did this, this would become cos x 1 minus sine x over 1 minus sine squared x. And you can see that that's really nice because then that becomes 1 minus sine x over cos squared x. That will cancel that, and I've got this. So it changes the whole look of the question, and we sort it out. Right, so that's what you knew about grade 11. Now let's see how this is going to change for grade 12. Well, basically, the only thing that's going to change for grade 12 now is you don't look for the most difficult side. You look for the side with the most compound angles. Okay, and that might mean the simpler side, and it could also mean the more complex side in terms of lots of things written down. So it would just depend. So let's try some more questions, and I'm sure you'll come across one and then you'll realize why I've gone through this with you, because the procedure does change ever so slightly. Right, I need to spend a few seconds now going through the general solution, because the very next question we get to requires us to know that. So let's talk about it. We know that if sine theta equals a, the first thing we know is that a has to be an element of minus 1 to 1. Why is that? Well, if I drew the sine curve, it would be as high as 1 and as low as minus 1. So if I went anywhere else, it wouldn't work. So what would I be able to do? I'd be able to say then that theta is equal to shift sine a plus k360, or theta is equal to, and I actually should have just put this a little bit lower, so I'm just going to take that off a bit, 180 degrees minus shift sine A plus K360, and K is an element of Z. That is essential. They don't always give a mark to this, but if you don't put it there, rest assured they're going to take a mark off. So always make sure you define your K. I got asked the other day whether we have to do it every time we write one of these down, so at the end of this one and at the end of this one? The answer is no, we don't. We just have to put it somewhere there. Right, then the next one is that cos theta equals A. And of course, this one, A may also only be an element of minus 1 to 1. For the very same reason, if we draw a cos curve, it will not go beyond 1 or lower than minus 1. So theta is equal to plus minus cos to the minus 1 of A plus K 360, K an element of Z. The last one is our friend tan, and tan theta equals A. And the good news is tan, the A can be absolutely anything. Now think about your graph. It looks sort of like this, doesn't it? And so in actual fact, it's going on forever up here. And so yes, A can be any value you want. And the good news is this is theta equals shift tan A plus K 180. And yes, K is an element of Z as well. Now, why is it an element of Z? Well, this has got to do with periodicity. Okay, every 180 degrees, we know that tan repeats itself, just like with sine and cos, every 360 degrees it repeats itself. And so if we're taking integer values, we're just getting the repetitions of the graph. Right, let's go to the next question. This asks you to prove this expression. Now, I must say that this is probably the most valuable proof you'll ever see. And I'm actually going to put it up. In fact, no, let's put it up here. You can see you want to prove this. Now, remember what I said to you. In these, when you're proving, you always work with the side with the most compound angles. And definitely these are the most compound angles. So we're going to start over here, and we're going to start on the left-hand side. And if I look at the left-hand side, I'm going to say sine A cos B plus sine B cos A. Now remember, I warned you that if there was a negative, we always have a little bit of a problem. So I'm going to have the negative there, and I'm going to use a bracket to make sure I don't make a mistake. Sine A cos B minus sine B cos A. Right, now if I take this out and I get rid of the brackets, I've got sine A cos B plus sine B cos A. Taking that negative through this bracket, I have minus sine A cos B plus sine B cos A. Now you can see that's incredibly good news, because if you look over here, that and that are like terms, so they fall away. And then if we add those like terms, we're going to get 2 sine B cos A, which is actually your right-hand side. Now, this is very important because there are lots of ways I can make this difficult for you. But this next one is a prime example of it. Hence, remember what I said to you? If there's hence there, sure as eggs, the thing you've done above is going to help you in some way. So in other words, what are they hinting at? If you look at this here, we want 2 cos 2x sine x. So they're saying that A will be 2x and the B will be x. So let's see if this will work. So if I go to the left-hand side here, do you agree with me? Instead of sine 3x, I could go sine 2x plus x. And over here, I could go the sine of 2x minus x. Now, if I do that, it fits this pattern exactly, which means I can go straight to the answer now of 2 cos, and in place of a, I put a 2x, and then sine, in place of b, I'd put an x. And I would have proved this in like one step. Now, you'd say to yourself, well, I'm not so sure if I'm going to remember this, but if I can encourage you to remember this more than anything else, because it's so useful and it often happens. A nice way they hide this is they'll do this to you. They'll say, prove that the sine of 80 minus the sine of 60 is equal to, and I must just try and think about how this will work out. I think it'll work out to be sine 20. If I'm wrong, just forgive me because I'm making this up as we go. So if we look at this, we would say to ourselves 80 could be written as 60 plus 20. And this could be written, oh sorry, this should be 40. This is 60 minus 20. Sorry, let me just tidy that up a little bit. It's a bit hard to see what's going on there with the splodge I've made. That's a 40. And so if I look at that using this abbreviation here, it would come straight to 2 cos 60 sine 20. And the cos of 60 is a half. And if you look at that, then look at how awesome that is. That cancels and you get the sine 20. So you will come across this in several different places. And you must just be aware of it and ready to go. Now notice this question's been mean because the very next question says hence again. Hence again because this time we're going to use this one to inform us, and maybe even that one, but it's more likely to be this one here. And if we look over here, look at this. We have got this, which is identical to that. In other words, we can replace this with 2 cos 2x sine x equals cos 2x. Now, we basically have to solve this equation. And you've got to just be careful not to fall into a trap here. So in other words, what I'm suggesting is you're going to say it's 2 cos 2x sine x minus cos 2x equals 0. Okay, now I'm almost feeling some people saying, but hang on a moment, couldn't we just have divided by cos 2x? Now the bad news is no, you could not. Think back to algebra. If we've got 2xy equals y, and we divide by y, what are we making an assumption about? We are assuming that y may not equal 0. And who's to say that that is true? In fact, it's definitely not true. So in actual fact, we cannot do that. What we do in maths, I know in science you can do that, but that's because you're often not dealing with variables that could be 0. So definitely, it's not a good idea to do it in maths. So what would we do in maths? We would say it's 2xy minus y equals 0. We would take out the y, we would get 2x minus 1 equals 0. And then we would say, well, that means that y is 0 or x is equal to a half. Similarly, we're going to look over here and say, oh, hang on, here's a common factor. Let's take it out. And that leaves me with 2 sine x minus 1 equals 0. And then we could say, well, that means that cos 2x equals 0 or 2 sine x equals 1, or if you like, sine x equals a half. And now it's time to use our general solution. So what we would do is we would bring our calculator up and we would say, right, we want to solve this one, so we're going to go shift cos 0. And of course, this is a special angle, so you could also just know that. And we're going to get 90 degrees. So we know that 2x equals plus or minus the angle I got in the calculator plus k 360, k an element of z. And so now we can divide through by 2, so x is equal to plus minus 45 degrees plus k 180. Notice even that is divided by 2, and that is extremely important. Do you agree with me that this actually means that the one solution is this, and the other solution is this? Now the sine one, we would do a similar thing. We'd pull the calculator up. Come on, calculator. Right, here you are. And we would go shift sine, and hopefully you know it's a special angle, but I'll just be good and do that. It's 30 degrees. And so I know that x is equal to 30 degrees plus k 360, or x equals 180 minus 30 plus k 360, and therefore x is equal to 150 degrees plus k 360. And you would now have what we call your general solution. I have stipulated this here, so it's actually fine. It will cover me there. And so all is well and the question is now at an end. So, right, at this stage, just to summarize, there's still a lot more work to be done on this section, but at least you've got a very good basic idea of it. But thank you so much for joining us today, and I do hope that you're nice and clear on exactly how this is used. Please remember my hints and advice to you to always know your formulas off by heart, because it just makes the whole section easier to handle. Thanks and have a good day.